Well, hello everyone. I'm absolutely delighted to welcome you to the first webinar in the series, What's the Future of Living in Bushfire-Prone Regions? My name's Mary Lush. This series of 3 webinars has been organised by the Friends of Lawn in association with the Areas Inlet and District Association, also known as AIDA. We acknowledge the Wadawurrung and the Eastern Maar as the traditional custodians of the Otway region. We pay our respects to them and their ancestors and look forward to a shared future. Now, there are a couple of housekeeping matters before we get started, except that the lovely thing about webinars is that you don't have to tell people where the toilets are. So this session will be recorded, but the fate of the recording is as yet unknown. We'll have to update you about that in later sessions. You have probably noticed that you're gagged, that is, you're muted and you're invisible, and chat's been disabled. Now, there's nothing, don't take this personally. It just helps to make sure the session runs smoothly. Zach Hooper-Travers from the Surf Coast Shire Council is our Zoom manager. The thing that you can do is use the Q&A at the bottom of your screens. You should be able to see that. And you can type in questions there, and you can do that at any time during the session. When we get to the Q&A, which will be after both speakers have spoken, Birgitta Hutchins from Forest Fire Management Victoria will take over, assisted by Mandy Baker of the Surf Coast and Colac Otway Shires. So on to the material itself. Fires aren't what they used to be. Just about wherever we are on Earth, unplanned fires are an increasing hazard. They're not just burning in California now as we speak. They're also burning in places that probably strike most of us as unlikely, such as Siberia. So in a sense, this first session revolves around that proposition that there are changes in patterns. And we'll be asking to what extent are these global patterns also seen in Australia and more particularly in the Otways? And also, what are the consequences for the natural environment that we value so much? David Lindenmayer and Stephen Farrell are our speakers tonight, and we're very grateful to them for their time. And we're very grateful to them for their energy. They're both extraordinary, energetic people. David will be the first speaker. He's from the Fenner School of Environment and Society at the Australian National University. He's an ecologist. Among the many things he's done, among many other things, he's done a lot of field research and long-term monitoring. And I know that long-term monitoring doesn't sound like rocket science, but I think it's probably just about as difficult. Because long-term monitoring is hard, there's not a lot of it done, which in turn often means that we don't have the information we need to understand changes in our natural systems, or for that matter, to work out whether our attempts at managing them are effective. Wherever we do have long-term ecological data for South East Australia, it's likely that David was involved. David's topic tonight is long-term insights into the impacts of and responses to wildfires in Victoria. So you can take the screen, David.
Thank you, Mary. I hope that screen is working and that people can get some sense of the topic. First of all, I have to admit that I haven't worked in detail in the area that is the main part of southern Victoria along the coastline, but we have worked for a long time in Victoria, for almost 40 years, and I hope that some of the insights from tonight will be relevant to people thinking about fire. Okay, so the recent Australian fires were unprecedented in terms of the extent of area of forest that was damaged. So the estimate from the most recent satellite information that we've been looking at suggests around about 12.3 million hectares of forest was burnt. And that's 12 times what burnt last year in the Amazon, which is about 903,000 hectares. The latest update on the number of animals killed directly by the fires is over 3 billion, and the economic cost estimated by John Quiggin at the University of Queensland is over 100 billion. So in a sense, this is really important to understand these first fires that we've just had in the last season. But I think it's really important to get a context of what's really happening here. So our recent analysis suggests that a megafire can be defined as something greater than 1 million hectares. And there appears to have been one megafire in Victoria in the 1800s, one in the 1900s, that's the 1939 fire. And there have been 3 megafires in Victoria since 2003, so that's just 17 years. And the data strongly suggests that the amount of fire in the landscape is increasing significantly over time. So this is data from a recent paper that we published about the Victorian fires and the extent of fires. Now, one of the things that's really important is that the amount of old forest in the landscape is declining dramatically, not surprisingly, as a consequence of these fires. And the latest data suggests that Victoria has lost 77% of its old growth forest across different ecological vegetation classes in the last 25 years. That's since 1995. So this is quite extraordinary in terms of what's happening. And really what that means is that there's a need to really think deeply about how we protect old forests, not only from things such as logging, but also from recurrent fire. And we'll come back to that in a moment. But one of the things that really is important here is not only just the fire that we've had, 2019-20, but to understand where the landscape is burning on a repeated basis. And again, we've been able to put together the data from across Victoria. And what it's showing is that there are extensive areas that are burning not once, but 2, 3, and even 4 times in the last 25 years. And so there are some really serious issues with the amount of fire that's occurring in the landscape, but how often that fire is returning. Now, many of these areas that are burning repeatedly should only burn every 75 to 150 years. And some environments in particular are very heavily impacted. For example, there is now only 3% of snow gum woodland in Victoria that hasn't been burnt in the last 25 years. Now, some of the vegetation types that would normally recover quite straightforwardly, such as some of these lower elevation mixed species forests, have been also burnt repeatedly. And in some cases, they're now starting to they're failing to resprout. So this clearly is going to have some major impacts on some of our forest ecosystems. What I wanted to do now is to very briefly move to this issue of fire and biodiversity response. And this work really relates to what happens in the wet forests of Victoria, particularly the Central Highlands, but there will be some similarities to what's happening in the Otways, although obviously some of the species are different. So we know that some species are killed outright, and this is a leadbeater's possum that was killed during the 2009 fires. But we also know that some species persist and persist quite well. So this is a mountain brush-tail possum, this species, and at the time of the 2009 fires, we had over a dozen radio transmitters on animals. And despite intensive fire at that site where those animals were being radio tracked, every single one of those individuals survived. And in fact, you can see their legacy through the genetics of the species at that site 10 years later. Now, some species colonise burnt sites almost immediately, and the sort of aptly named flame robin is a very good example of that. So these animals became incredibly common immediately after fire. And in these wet forests, it's actually the only early successional specialist. So it's the only species that's strongly associated with relatively recently burnt forest. And some species, such as the greater glider, continue to decline for prolonged periods of time after fire, largely because of the changes to habitat. So This animal has declined dramatically, not only in Victoria, but also in New South Wales. And it's potentially going to be one of the first species that was previously very common to go extinct in southeastern Australia. We just published a paper a couple of days ago indicating that the greater glider, its decline looks to be pretty close to 80% in the last 20 odd years. Now I wanted to talk about some other work which is really quite instructive in helping us to think about what happens in areas after fire. So this is Budderie National Park, work that started in 2002 and continues to this day. So this is south of Sydney, about 200 kilometres, and it's a largely intact area of heathland and woodland that has some of the best fire history data anywhere in New South Wales. And these dense interconnected heaths are burnt roughly every 20 years. So an old growth heathland is about 20 years old. And these kinds of environments are very important for biodiversity. And it's an area that we've studied repeatedly. This slide was taken about 3 or 4 weeks after fires in 2003. And what's very important for these areas is that iconic species such as the eastern bristlebird persist in these heavily burnt areas where there are patches of green that remain. And the more the green in the landscape, the greater the patchiness, the faster the recovery. And there's several things happening here. One is that part of park management in this iconic area is very heavy fox baiting, very intense fox baiting. And we see a pulse in introduced feral predators immediately after fire. And it's actually the time that park managers have to work very hard to knock down populations of these animals. And most of these species will persist in the absence of those feral animals. The other thing that's really important in the context of these kinds of heathland areas is that the number of fires over time is really important. So for every extra fire in the system, it drives down species richness quite dramatically to the tune of nearly 10% per site, per fire. Now I wanted to talk about something that's a little bit more complex. This is to do with what we call the science of interactions. This is how things interact in the landscape. So different kinds of disturbances. So one of the things that's really important that we've discovered, particularly after the 2009 fires, is that the condition of the forest before a fire has a really big impact on how the forest recovers after the fire. So what that means is that the pre-fire condition of a landscape and of a forest makes an enormous difference. So for example, we can see in these kinds of wet forests that are then burnt, what we see from the monitoring is that the severity of the fire is much lower. Animals are much more likely to persist in these kinds of forests that are old and then burnt. The recovery is faster. For example, we get a lot more seed regermination. And we see that animals and plants are recolonizing these sites much faster than if a forest looks like this, that's been logged and then regenerated and then burnt. The other thing that's really important is that fire tends to burn much more severely in young forests, which is then regenerated and is regrowing. Now, this is very controversial work, but we now have a whole series of additional data sets, including stuff that we're analysing right at this moment to see this relationship. So this is a graph from a paper published in 2014 with Chris Taylor as the lead author. And what you see in the little graph is the probability of canopy fire, what's called a crown burn. And as we see along the bottom axis, you can see the age of the forest. And what happens is that these wet forests don't burn for the first 7 years. And then there's a very steep increase in the probability of canopy fire, almost 7 times increase, until the forest is about 40 years old, and then it starts to reduce in the risk of high severity fire. Now, this is not a one-off. We see almost an identical curve from the most recent work that we've been doing with fire data from the 2019 and 20 fires. Same sort of pattern. So this is age of the forest along the bottom and the probability of what we call a crown burn along the top. The other thing that's important is that this kind of relationship is not only seen in wet forests, which is on the far right side of this graph, but we also see it in lowland forests and drier forests, not unlike what we see in coastal northeastern Victoria. The other thing that's really important here is that when we start to look at these data, if you look at the second graph, graph B here, and this is from a paper that was published, is about to be published this week, the probability of crown burn is strongly related to whether or not the forest is being thinned or not. And we see that thinning either has very little effect on reducing fire severity, or in some cases, it actually makes forests more likely to burn at high severity. So the idea that if we thin lots of forests, we will be able to solve these problems of fire severity is not supported by the data as we've been analysing in the last few months. And you can actually see that when you go out and you measure lots of areas that have had different histories, including a thinning history. Okay, let's come back to Borderee National Park again, because I want to talk about this idea of interactions, because it's something that we've studied in detail. Now, one of the important things in Australian mammal biology is that we've lost roughly 10% of the nation's mammals, largely through the impacts of feral predators. And so Borderee National Park is notable because feral predator control has actually been very effective in this ecosystem, but it's also had some other impacts. And one of them is that the populations of herbivores, particularly macropods, such as swamp wallabies and eastern grey kangaroos, have actually increased quite dramatically. And there's a very interesting interaction that takes place between the numbers of herbivores in an ecosystem and fire. Essentially what happens is that when ecosystems burn and then start to germinate and regenerate, much of the vegetation becomes much more palatable for animals. And that has quite marked impacts on ecosystems and then cascading impacts on other species. So let's look at data. Data is really important in all of these discussions, and that's what our group specialises in. So you can see here somebody reloading a fox baiting poison bait station. And in these poison bait stations, we have data on how many fox baits are taken by predators and how many detections of animals are actually made through footprints in the sand plots. And you can see the trend curves for fox baits that are taken and detections of animals. So essentially the fox baiting has been extremely successful, particularly after fire. We know that feral animals will often move up to distances of up to 12 kilometres to feed and forage in areas that have recently been burnt. At the same time, we've also seen very substantial increases in macropods, such as the swamp wallaby. So what we wanted to do was to look at what happens when you have fire and you have macropods, and then how they interact, and try to understand the interactions between fire, herbivory, and the interaction, not only on the vegetation, but also on fauna. So to do this, Claire Foster, one of our researchers at ANU, set up a series of exclosures. And these have been in place now for close to a decade. And we had exclosures that completely excluded macropods. Then we had control areas where macropods could go anywhere. And then we had another set of exclosures where macropods were allowed in for some of the time, but excluded for the rest. And when you have fire, but no macropods, you get these very complex, very species-rich ecosystems that recover after fire, like we can see in this photograph. When you have macropods and fire, what you see are two unpalatable plants, bracken and flax, and essentially nothing else. And we see a highly simplified ecosystem with very few small mammals, almost no reptiles, and completely changed vegetation cover. So one of the major implications of this is that if we do supplementary feeding for herbivores after fire, and you'll probably remember large areas of southern Australia being bombed with sweet potato and carrots to support herbivores, we need to think about the impacts of those elevated population numbers on the recovery of an ecosystem, and then the cascading effects on other species that depend on those ecosystems. So that was something quite unexpected, but very important from the work that comes from Budaree, but relevant to many other systems in southeastern Australia. So I'm going to summarise with a couple of last slides. The first thing is we are seeing huge increases in the amount of fire across many landscapes in Victoria and in New South Wales. There are massive losses of biodiversity and ecosystems are changing. For example, we're losing extensive areas of forest that are unable to recover because there's no seed left in the system, or trees are starting to fail to resprout. We understand that fire interacts with other processes, such as fire begetting more fire or logging influencing fire severity, and we need to be very careful about how we manage those interacting factors. We also need to be careful to watch for too many herbivores early in the regeneration phase of some of these ecosystems, and we need to be very careful about making forests more prone to more fire. And we've been arguing recently, and we'll continue to do this, that we think that logging should be excluded from areas close to towns. The other thing that's critical, that's coming out from several different studies in different parts of Victoria, is that older forests tend to burn at much lower severity. And so one of the key things here then is to try to grow more older forest. And given how much old forest has been lost in Victoria in the last 25 years, 77% of what occurred in the state in 1995 relative to what we see now, it is really important to try and grow a lot more old forest in the system. So I'm going to leave it there. That's a short vignette of a lot of the work that's been done in the last 3 to 4 decades across the state. And I'll be happy to take questions later. Thank you very much.
Okay. It's very terribly hard to take in all these aspects of ecology and the scale of the problems arising from fires, I think. And it's particularly hard to keep it in mind when the conversation turns to human property, or to somehow get some sort of perspective between ecological concerns and human concerns, I suppose. But we are making an attempt to do that in this series. We'll hold questions for David until after Stephen's spoken. He's the next speaker. So that's Stephen Farrell. Stephen's a forester by background, and he's also a founding partner of Spatial Vision, which is a Melbourne-based consultancy. And in a sense, like David, he's a data man. Stephen's been heavily involved in work along the Victorian coast. A few years ago, for example, his work helped to identify the places most at risk of erosion from rising sea levels and other coastal erosion influences. Apollo Bay, as most of the audience will be aware, is one of those places. Steve's now working on climate trends and extreme events in our region, and his title is Trends, Futures and Extreme Events. So your turn, Steve.
Thank you, Mary. Thank you. I'll start sharing my screen. Well, thank you very much. Thanks for the opportunity to speak today. Yes, I'm a forester by training. I deal with spatial science these days, and I have worked in government years ago, and now with a private company. My background has been actually in this region with Otways Forest Management Plan. I was involved in preparing that back in the late 80s, early 90s. Actually, we talked about the greenhouse gas effect at that stage and the concerns about climate warming and what it might do to rainforest. I've also undertaken old growth forest studies across the state and would have worked through the Otways here looking at old growth in the mid-90s. And as David just mentioned, all the fires since have largely impacted on the assessment work that we undertook during that period. So what I want to talk about today is you know, these magnificent, I'm just going to go back. This magnificent region, really, where you've got the forest meets the coast, where we understand, you know, we know we've got some of the biggest trees on the planet. It's an area that is quite majestic, but we know it's also undergone significant change. And so I thought as a good forester, I'd show you a few snaps that you probably are familiar with, but I think when you get into the West Burrow and look at those big trees and the big trees reserves that survived, not just fire, but timber harvesting, there's a number of sites that do keep a log of them and keep track of them. But certainly they're quite exceptional, and they also give you a clear understanding of what it is that is unique about this region. I guess when we think of the Otways as well, we think of an area that an older photograph. We think of an area that is moderated by the coast, that has a very high rainfall really up on the ridge areas, and hence why we have those forests. But it's an area like all others undergoing change that David alluded to. I'm going to present a view of the current climate, and in terms of the current climate, I'm going to talk about what's been happening in the climate up until recently. And to do that, we look back over records. I've mentioned there that we're going to mainly focus on the climate by way of the rainfall, annual rainfall, monthly rainfall, and temperature, mainly maximum temperatures. And that's sourced from a site there that we use for a lot of our work. I'll also look at then some of the projections going forward, work that was published last year by the CSIRO, and what we've been doing with that work, where there's a significant amount of global climate models and different scenarios, and we've picked one of those really to present today based on other work we're doing. And then we're going to reflect on what that possibly means for unplanned fire, and reflect on what the trends we're already observing. In doing that, I guess I'm going to draw on work that we've recently undertaken for the Barwon Regional Partnership Councils, which include Surf Coast, work that's been led by Brian Roberts from DWELP, and Peter Ashton there with the Surf Coast has been heavily involved. And so some of the work we present will be work that's been sort of formulated during that process. So in terms of the climate projections, just for background, there's a particular model that we've adopted based on advice from CSIRO. John Clark at CSIRO suggested that was the best consensus model for the region, for southern Victoria largely. We've also looked at a higher carbon emission scenario, and the results therefore are for that, rather than to present lots of different scenarios and confuse you. I guess the important point to be made is that a lot of the climate change which we are experiencing and will experience is largely locked in because the carbon emissions have already occurred, and we know that the next 30, 50 years it will change based on our longer term carbon emissions, but the climate we'll see over the next 20 odd years is certainly going to be fairly locked in. So what I want to talk about is a bit about annual rainfall. And I've just gone to a simple map that the Corangamite Catchment Management Authority have for the region. I think it's good to look at the context of Lorne, given that that's your focus, but I know others come from afar. We know that right on the ridge through the Otway Ranges is where you certainly have significant rainfall, some of the heaviest rainfall in the state. We know there's controversy over record keeping, but we know that there was a particular farmer who certainly was very good collecting records that we presented there on the ridge, and we know that it averages probably nearly 2,000 millimetres per year, and it gets up to 2,500 some years. We know Lorne sits to the east, and we know the rainfall drops or reduces as you lose elevation, but also certainly as you go north. And in fact, Winchelsea is in a rain shadow of the Otways, gets only down to 600 mil, it gets as low as 600 mil on average. And we know as you go further east, the rainfall reduces as well. Coastal influences along the coast, and we know about prevailing wind directions generally from the different seasons. And I won't go through that, I'll just talk about rainfall and temperature generally. And what I'll do is present some of the basis of the modelling work that we've been applying and drawing conclusions from. And this is just a simple way of presenting the what you're looking at are 5 by 5 kilometre grids, and looking at every one of those grids and saying, well, what's the average climate for this based on the modelling or based on records that have been kept over the years. So here's a baseline view. This is the last, well, it's a 30-year period, which includes a millennial drought, which ran through the 2000s. And so it's 30 years of record keeping an average sort of climate for that period, for that region. And I'm showing this grey area because I'll come back to that. I'll focus around lawn because I think if we're going to look around about what's happening around lawn, I think we need to look at the areas to the north and east and west, sorry, particularly, and those wetter forests that those large trees are located within, given that, as we know, to the north and to the east, it does dry out. And so looking at the rainfall lawn, we know it's around, you know, the high 800s, it's into the maybe 900, gets to 1,000 occasionally. It's up over 1,000 already, I think, this year. Anyway, so we've got significant rainfall at lawn, but it's higher as we go further to the east and west and southwest, up into the high elevations. That's our baseline view. Going forward, what are the projections saying at the moment? Well, actually, by 2030, it's a 2030 view, it gets a bit drier up north in those sheltered areas, in those areas of rain shadow. As we go further north, it gets a bit drier again. As we go, sorry, further in time, it gets a bit drier again. But really, what we're seeing there, if we go backwards and look at those changes from baseline to 2030 and 2050, look, you're not seeing a significant drop off in rainfall in the projections at the moment with most of the consensus models. I'll come back to that. Temperature. Rather than just look at temperatures, I think it's good to pick a threshold temperature, 35 degrees, no warm weather, warm days. And we're going to just walk through a bit of a story with what it means in terms of, well, fire, but also just a general understanding of the drying of the region. How many days you get over 35 degrees? So again, we're just going to that same sort of set of views. We're starting with what's been historically the situation in lawn with the number of days over 35 degrees. These numbers will lower than probably I experienced, but that's I thought I experienced, but that's all right. But these are averages. These are over a 30-year period, and you can see where lawn sits there, sort of, you know, nearly a couple of days of over 35 degrees at the moment. In the future, probably getting closer to 2.5. You can see there, if you look back, how there's, you know, more areas to the south there in those wetter forests, getting more days over 35 degrees. And as we get into 2050, certainly well north, you're getting many more days warm inland, as you'd expect. You're getting a coastal influence on the around lawn, but it's still a significant reduction or increase in the number of days over 35 in the middle of summer in January. And that's probably not unexpected in what you're looking at in terms of broader climate changes that are anticipated. I guess what's good to look at though is also pick a month like December, which is you know, the early days of summer. Really, we don't we start to get some warmer weather, but we know by January, certainly by the time kids go back to school, or the kids go back to school, February, it's certainly we've seen some very warm weather. December, at the moment, we see that yes, there's less days. That blue colour there around lawn, so south, over 35. But moving into 2030 projections, moving into 2050 projections, we can see significantly. I just go back through those. That's the baseline today. You know, maybe you get 1 day every 2 years. Into the future, probably some of those areas start to move towards a day, and then you start to get into a couple of days in areas in those wetter forests. And I guess that's where one of our, you know, interesting and concerning probably aspects of a drying climate come from, and it reflects partly on what David was just reporting before about what sort of changes we're seeing already in the landscape. What I want to do now is I want to just focus in on an area that will encompass lawn as sort of a central area. It goes down to Wye River, up to Aries, Deans Marsh in the north, Forest in the west. because I'll just put an average climate across that region and just reflect on that a little bit more. And here's what we're being seen by way of annual rainfall. So here's what's happened over the last, say, 50 years. The blue on the far left is the 70s. The right is the last 10 years, the red. And I've drawn that dotted line because that's where that average climate is coming from. It's coming from the 80s and 90s and the 2000s. And remember, the 2000s there represent the millennial drought, the very dry period we had. And so that dotted line is the average climate that was used in those various views you saw before, and I'll take that forward now. But you can see we get a fair variation, and we can see the last 2 decades have been very dry. Going forward, down the bottom right there is where that baseline sits in terms of being, you know, just over 1,040 mils for that region on average as rainfall. Projections, as we saw before with those map views, sort of not showing a lot of change really into the 2030s over the next 20 years, over the next 10 years. And then as we go forward to 2050. Now remember, this is an average based on 2018 and 2020, 1981 to 2010. And so we're probably already seeing some significant, you know, climate rainfall less than what we're seeing here in the averages. But that's the nature of these changes. I guess a very important point to make at this point before we go further is knowing that don't think of climate change being this gradual change. Don't think of it being that everything slowly gets warmer, things might get a bit drier slowly. Think of it more as broad cycles, as you know, with the climate that occur today. And think of it in terms of episodic events where you may have a period which is very, very dry or very wet, but there's going to be periods where they'll change, that the climate will change for a spell and it won't go back to another climate. It will go to a new step in the process. So we do get these irreversible steps occurring, which we can find in the data if we look hard. So while this is a broad trajectory of climate, don't think of it as sort of a gradual change that you'll experience. And in saying that, of course, we get variation throughout the months of the year as well. And so if you're looking at that climate that we saw before over the last 50 years, the red line there shows the last 10 years again. And it shows how, particularly in the spring, we've had 2 very poor or drier decades really of spring during the millennial drought, but also the last decade as well, compared to those 70s where it was a higher rainfall overall, but also much wetter springs generally. And you can see the difference in May too. You can see how that over the last May, the last 10 years, Mays have been quite wet, much wetter than they had been. Those autumns have been much wetter than they had been during the millennial drought period, which really added to the problems of the overall annual rainfall for that period. So, you know, seasonality of rainfall is terribly important, obviously, and changes we experience just in the normal patterns that we've already noted over those 50 years. Going forward, the projections, what do they say? Well, the graphs sort of move all over the place. You can see the blues, it's the 2030 view, the red's the 2050 view. But what's interesting is noting the real drop in late spring rains and what that might mean by way of dryness in the climate, dryness in the landscape. And the other is storms and intense sort of weather activity, possibly into the later parts of summer. So January's there showing much higher rainfall. So, you know, this is only a model, it's only a projection, but it sort of reflects a little of what we're seeing, but it certainly takes another dimension too. And that's what we're sort of just been observing. Let's have a look at temperature as well while we're at it. So let's look over the last 50 years. What's been happening with those temperatures over 35 degrees? Again, the dark blue is the 70s, the red is the last 10 years. What we're seeing there is we really have had hotter, you know, more days over 35 degrees, both in December and in January, significantly more. And we've seen that in the millennial drought. Yes, we might have had hotter February, say, and even hotter Marches, but you can see the trend there generally across those decades. Each December it getting that bit, a number of days of 35 or more increasing, and generally an increase there in summer as well, in January and February. So going forward, the projections are not dissimilar, you know, showing that that grey line there is the average for the last 30 years between 1981 and 2010. And we're looking at 2030, 2050, and we're looking at, we're looking at more days over 35. But importantly in this, you're also looking at November as well, looking at days over 35 in November, but a significant increase in December. And so that concludes, or we conclude it does mean a drier landscape and certainly drier forests. And I guess it's not surprising that you probably are well aware the pipe that's been put down from Melbourne to Geelong, looking at some of the projections for the West Burrum Reservoir, a major reservoir down your way, and noting that the modelling has shown how that drying, that warmth in the landscape, that drying of the landscape has resulted in probably less inflows into the key reservoir. Although, you know, not long after this, I understand it was quite wet the later part of 2019. But at the same time, you know, it's a long-term trend that we're looking at here, and that's where we've got to look at the data, what it tells us in terms of what it means for all issues, water or even fire related. So moving from that, I'm just going to talk about a little bit about what it means for fire, this will be quite brief because I just want to then draw it together for what those climate parameters sort of may mean. Wildfire in the landscape, David alluded to this. I've just got there sort of a summary. As we know, there was big fires every 70, 80, 100 years. We know that, well, this photo sort of tells a story too there, though I think they probably lit it to clear it, but very big old trees on the ridge up in Beechworth, Beech Forest. And obviously when you're a forestry, you always know your ages of fires because you know how old the regrowth is generally. But 1851, big fire, burning out in the west, came through the Otways. A range of fires. It picks up obviously the ones we know of in recent history, the Ash Wednesday fires of February 83, and more recently the Wye River fire. So we know there's a good checkered fire history, and if we look at a view of that in terms of the last 40, 60 years, we know that the yellow there is the 39 fires, not necessarily well mapped, and this doesn't necessarily map the severity of the fire, the scorch classes, some of what David showed before in terms of that more detailed mapping, but it does give you a general idea of which landscapes have been subjected to fire over which period. We know the 83 fire that burned largely around Lorne and to the north east there in the townships. But certainly this is a landscape that settlements have really, had challenges with over many for an extended period. What's interesting, of course, is this area on the ridge, the wet area, the area around Beech Forest, the area where we have that higher rainfall, where we still have some very large old trees, areas where I think we have the cool temperate rainforest, and unique ecosystems, but as Dave was alluding to, still some old growth forest in those regions. I guess this is showing how landscape fire to date has played a huge role in the landscape, but there are areas that we know have been very wet and haven't been subjected to fire as regularly as other areas. So what does a fire? What do the climate trends mean, or what can we conclude, and what direction does it give us in our planning efforts? I guess I decided to show this one slide because it sort of was driven out of a talk I heard recently by Associate Professor Trent Penman. I never saw his slides. I actually just heard the talk. It was online on a podcast, I think, and I've got a reference to it there. You can look it up on the Melbourne University of Melbourne site. It's on actually Radio National's Big Ideas podcast as well. But he raised this idea that think about a fire regime being driven by 4 key factors, or he called them the 4 levers, or yes, 4 levers anyway, that we can look at that will influence the likelihood of wildfire in the landscape. So he said a fire regime could be driven by The biomass, David talked about biomass. He talked about the fact that thinning doesn't do an awful lot, and this is, you know, coming out in some of the other evidence to suggest that, in fact, you know, the amount of fuel and biomass in the forest, you know, it gets to a certain point, and it doesn't really matter if there's much more at all. It's just the biomass is there, and it's a fuel for fire to occur in the landscape. We need ignition, of course. We need a spark to form that, to have fire start. We know, I always know when I worked in Colac and in the Otways, the rubbish chip was always a major source of fire, fire starting. But of course, lightning strikes in the natural landscape are also terribly important. And one of the very unique things, you've probably seen the research and the findings, that for the 2019-20 season, the one we've just experienced, lightning's accounted for 60-70% of the fires. Unlike long-term averages where it may be down to 10%, an awful lot of fire was started by lightning strikes, and it's something to reflect on when we think about changes in the climate and what we may be witnessing in terms of extreme weather events. The other area, of course, is fire climate. We know that too well. Many of us will know those days where you look at the, you know, the temperatures, you see the wind direction, you see the humidity, and you just hope everyone does the right thing, or hope nothing terrible happens. So fire weather is a terribly important factor, and we're going to have others talk, I think, in these sessions about fire weather and behaviour and what have you. But temperature, wind, humidity, but importantly, and David mentioned as well, these gaps in extreme weather days, less gaps. We see that occurring in the forecast. We see it occurring at the moment, and that's what was certainly a key factor over the last summer. We didn't get the breaks that we anticipated or have had in the past. But at the top there, the last one after fire weather, fuel dryness. It's another element of fuel, but it's a critical one that is becoming more and more important as we think about landscapes and how they dry out. And this comes back to that seasonality of rainfall. If you have very dry springs, if you have much warmer temperatures, those warmer days starting earlier, that lead to these longer summers, you know, dryness in the November, December period and well into the March period. These are all factors that influence how dry and how flammable it affects the moisture content, therefore it affects the flammability of that fuel in the forest, particularly. And I guess this is a critical factor that I think we're now just witnessing, how drought in the landscape combined with changes in the weather patterns, such that we don't get the breaks, together with ignitions and sparking, are the critical areas I think we need to be concerned about and plan around in our preparedness. And I think, you know, while a lot of people are focused on fuel biomass, I think we need to be recognising these other elements of the fire equation. So I thought that was my concluding comment when I'm talking about weather. And so that's my thank you. And I should say that my brother gave me some photos, so I put his name down the bottom of the presentation. So thank you.
That's Steve. I wish I had enough words to kind of summarise what I've just seen. Certainly is a stark amount of data that you've gathered to demonstrate, I guess, how our climate is changing and the potential impacts of that. So my name is Brigitte Hutchins. I work with DELP. I work in a program called Community-Based Bushfire Management. So, you know, supporting these kinds of community-led initiatives is pretty much what we love to do. I've got to take my hats off to Friends of Lawn and to Ada for all the hard work and getting some pretty amazing speakers on board for this series of events. I have got to facilitate the question Q&A session of this. We've actually run a bit close to the end of our time at the moment, but we've been texting saying we better move into 8:45 or even to 9 o'clock for a finish. We haven't got too many questions, but yeah, myself and Mandy Baker from Colac, Otways Shire and Surf Coast Shire are going to try and collate them and carry on with some themes. We've also got a local expert, Aaron Ledden. I'd like to introduce Aaron. I don't think we can see you at the moment, Aaron. So Aaron actually works with Parks Victoria. He's a ranger in charge, fire and emergency in our Otways patch. He's based in Anglesey and he also lives locally. Hi, Az. I can see
Good
you
evening,
now.
everybody.
He manages multiple work streams throughout the Otways and beyond, and he has a great knowledge of the landscape and the infrastructure in our national and state parks. And also the strategies that basically support or sit behind a lot of the operations he's involved in. Aaron's team also works closely with communities in our patch on multiple projects. So great source of local info and intel. And I'd like to thank all of our presenters and Aaron for being available for this session. So I guess just to start with some of the questions, David, there was actually a request for the name of the papers that you've cited in the presentation to be available for our viewers at some point. So I'm sure we can organise that with our admin. So there's a couple of questions that really was around the same thing, David, about is the thinning of the forest that you refer to the same as, and people have written back burning, but also planned burns, I'm assuming that's what they mean. Is it logging and planned burns, or is it logging that you're referring to in the thinning of forests, old growth forests?
Okay, so the most recent paper that we've published, we did the page proofs a couple of days ago for, and it looked at commercial thinning of dry forest and wet forest, and looked at the severity of fires in thinned versus unthinned forest. So essentially it's what we call a multi-way interaction. So we were looking at the type of forest, the age of the forest, and whether it had been thinned or not. And largely the takeaway message is, with commercial thinning of forests, either thinning makes no difference to fire severity, or it tends to contribute to fire severity, which is, for some people that'll be a bit unexpected, but essentially it's likely that it's changing microclimatic conditions. There's a couple of cases where it reduces severity in younger forests, but then it contributes to severity in older forests. Okay, so that's the thinning component of the work. The other work that's been done is looking at the age of the forest and forest history, and then the fire severity in forests of different ages. And that's now been extended to parts of eastern Victoria following the most recent fires. So the general data sets that have looked at this issue are showing pretty much the same shaped curve as what we're seeing. So it's what's called a left skewed inverse polynomial. So it's basically skewed to one side, and so forests tend to burn at higher severity for the first 10, 20, 30, 40 years after they've been regenerated, and then there's a long tail coming back to forests that are very old. Now, the most important thing here is that the key driver of fire is actually climate and weather. And underneath that, once you take into account those things, then you can start to look at other things. So we routinely do this with our work on house loss, on fire severity, on thinning, all those kinds of things. So, what Stephen was saying before about the importance of climate is absolutely right. You've got to take into account climate and fire weather, but then you need to control for those things, or at least take them into account to be able to look at other things in the data sets. So our most recent work in northeastern Victoria, the 2019-20 fires, is looking at 34,000 points across the fire footprint in terms of what's happening. That's I'm happy for people to to seek out the papers on that, I'll provide anything that's there. There's a summary of about 40 or 50 papers in that short spiel earlier that I gave. I'm happy to send those to people and to follow up.
Yep, that would be great. So in a nutshell, I guess, you know, because we are getting quite a few questions about commercial thinning v planned burning, and I'm thinking what you're saying is commercial thinning is logging.
Commercial thinning is a stage where people enter the stand, usually when forests are young, to thin out forests. So this happens in plantations as well as in native forests.
Yeah.
And in more recent times, it's been proposed by some lobby groups that thinning will help tackle fire problems. The evidence from Australia that we've seen so far is from empirical studies. So this is not models. This is actually data that comes from actual fire events and actual stand histories, is that thinning is not going to be your answer. Now, thinning is different, obviously, from prescribed burns and hazard reduction burns. And the data on hazard reduction burns indicates, and this is from 2009 fires, that hazard reduction burning does have an effect on reducing house loss, but by and large, it seems to be most effective when it's done relatively close to urban settlements and it's done relatively frequently. That's work that was led by Phil Gibbons, published in 2012, and I can make that paper available as well.
Yes, and we'll make sure that we communicate through the Eventbrite invites with our people who've registered around that. And I suppose an observation that's also come out is the initial map where you showed the severity of I suppose, mega fires or frequent fires, and the Otways was remarkably less impacted than some other parts of Victoria. Is there any data or information that you could provide around that?
So the data on recurrent fire comes from a paper that was published a few months ago, Proceedings of the National Academy of Sciences of the USA. And essentially what was done there was we overlaid various data sets from the Victorian government. So where there'd been fire, how severe the fires were, how many times particular areas are burnt in what years, going forward from 1995 to 2020. And that includes the footprint of the recent fires, 2019, 2020. So again, I can provide that work. So that allowed us to calculate the size of the fires, where they were occurring, how frequent they were occurring, yep, but also which ecosystems are burning and reburning. Mm. So some of the most extensive reburning is taking place in the wet and damp ecological vegetation class in central and northeastern Victoria. Mm. And so that system has sustained enormous amounts of widespread fire over the last couple of decades. So much so that there is now a seed shortage, and there are fairly advanced projects looking at harvesting seed to look to see if they can start to regenerate forests that have been burnt simply far too many times in the last few decades. So the issue there is that the forest needs to reach a certain age before it can provide effective, viable seed. And if it gets burnt before that, before it's mature, then the forest is potentially lost and has to be regenerated artificially. So they're the kinds of issues we're going to be dealing with in the next 20, 30 years. As climate heats up, we have more fires, we have more frequent fires, we have ecosystems trying to learn how to deal, or trying to adapt to fire regimes that are outside the range of normal variation.
Yeah, I was actually having just a giggle about the amount of work that we're all giving you here, David. appreciate all your follow-up.
Well, I'm happy to send out material. It's there. Almost everything that's been talked about tonight is based on empirical analyses of real data sets.
So we also have a question for Stephen, and I've got to say, David, your reflections on all the different attributes to what makes unplanned fires happen, and the way that you and Stephen have basically complemented each other's data is really interesting. So I've got a question about La Nina and the bomb. There's apparently a prediction for a 70% chance of La Nina this year, and this is a holy grail question. Will this make bushfires less likely in the Otways, Stephen?
Well, the answer is yes. It's an interest. As we know, wetter springs mean probably more grass growth and greater moisture content in the forest. And so, generally speaking, we will tend to have more grass fire, depending on ignition sources and everything else. But generally speaking, the forest fires are less likely given the current outlook. It has been a wet spring in parts, and I think the expectation is it's not going to be such a difficult season. Saying that, of course, it was terribly brave. But I think that's the feeling, and I think you'll see that across the board in terms of some of the planning work that's going on. So that's my general understanding, that it will be a better season than it would otherwise have been. So that's the general trend. Yeah. Yeah. Of course, they're rare. These events. The opposite is probably more frequent when the currents go the other way.
And I guess it'd be a good time to just check in with Aaron around our current rainfall down in the Otways.
Yeah, Birgitta, I think we had a really good early start to autumn, but if I look at across the last sort of 6 or 7 weeks particularly, it's actually starting to dry out quite quickly, particularly in the eastern part of the Otways. And I look at that eastern part, you sort of look at the Deans Marsh Road to the east and our drier foothill forest into our heathland communities around Anglesea. But we're also seeing further to the west, to even close as far as sort of Kennet, those forest types through there, particularly with a dry late winter and a dry early spring, are starting to dry out as well.
Yep. Now the forecast is for average rainfall.
We've got a huge array of different questions here, and I'm really mindful of the time. And I just want to, I suppose, acknowledge some of these questions and also remind everyone that we have got another 2 sessions around similar topics, and I'm sure that some of those questions will probably be answered in the next 2 sessions. We do have a question about cultural burning. I don't know if any of our panellists, or Aaron or David, would like to talk briefly about.
Yes, I'm happy to have a little bit of a go at that. Yeah. The concept of cultural burning's had a lot of airtime in the last 4 or 5 months, and I think that's to be welcomed. There are some important nuances in the concept. The first one is that at the time of white settlement in Australia, Aboriginal Australia was really 350 something nations, and fire was used differently in different ecosystems for different reasons by men and women and different groups. And they were largely using fire for reasons other than asset protection. They were using it for hunting, for growing green pick, for bringing on tubers if they were harvesting particular kinds of plants. So there's some deeper thinking to be done in this space, and it needs to be done in a very culturally careful way so that, once again, white people aren't stealing Indigenous people's intellectual property. That's one issue. The second thing is, I think there's a really important role here for a merger and a collaboration of Western science with Indigenous science. And where we practice cultural burning, we need to think carefully about what's being burnt, why it's being burnt, what are the responses, what did it look like before the fire, what does it look like after the fire, what's the fire regime. Fire regime is the sequence of fires, all those kinds of things. And so there's a need to really think carefully about that. And that means that some of the best places to practice cultural burning is where we already have existing large-scale long-term studies to really understand what's happening. That's critical. The other thing that's really critical, and Stephen pointed out some of these beautiful areas in the Otways where they're long unburnt, and cultural burning is probably not appropriate in some of these long unburnt cool temperate rainforests and extremely wet forests. So it's not a broad brush solution to be applied uncritically everywhere.
Yes, that's really comprehensive. Thank you, and informative. I think there's been a huge focus on it since our Black Summer. There's also another question for you, David, about, and this has been a couple of people have asked this. Tell us a bit more about growing old forest, please. Gosh,
okay. Growing old forest is an enormous challenge given we've lost 3/4 of it in the last 25 years. And clearly that's not sustainable in terms of the old growth estate across not only Victoria but elsewhere, such as New South Wales. So growing old forest can be done in a sophisticated way, and that is that when we've looked at old growth forest in the past, we discovered that it's more likely to occur in certain kinds of places, and that was implied from what Stephen was showing with climate maps, and elsewhere that sort of work's been done too. So flatter terrain, cool south-facing slopes, deep valleys are the kinds of places where we're much more likely to get old forest. And so it's still possible, even under climate scenarios, to pick out areas where you're more likely to see those kinds of areas of old growth forest either surviving or more likely to develop into the future. So they're the kinds of places that we might want to target for protection. And it's possible that you might want to apply some hazard reduction burning in drier forest types adjacent to some of those areas that you're going to work to protect as examples. So one of the important ways of growing more old forest is think about the numbers of drivers and stresses in the system and where you can work to take some of those drivers and stresses out. And in some cases in central Victoria, that will mean removing logging from some of the more important potential refuge areas that will be very valuable in the next 10, 20, 30, 40 years, given what's happening. So there are ways to do spatial planning with an understanding of the environmental fabric of a landscape to work out where you might do certain kinds of actions versus others. The other thing that's really important is that old growth forest is a concept that's associated with particular ecosystems. So an old growth woodland is different to an old growth forest, which is different again to an old growth heathland. And one of the difficult things that's happened in Victoria is that the definition of old growth forest has actually been changed. So in 2013, it was a forest had to be 120 years old. And then it got changed to a forest has to be 250 years old. And that immediately drives down extensively the amount of old forest there is. It also makes it much harder for forests to be old. And often what we need to do is to think about where are advanced regrowth forests that you might want to protect to be the next nearest old growth forest in the landscape. Yep. So there's some thinking that can be done there that can really change things.
So a really strategic and systematic, evidence-based approach.
And I think going back to the definitions that we've had in the past, given how much we've lost in the last 25 years, making definitions much, much harder for forests to be old forest is actually a retrogressive step.
Yep. Okay, thank you. Now, we are getting on in our time. There is a question here for Aaron, which is based on the drying trends that Stephen spoke about. How do you think that this may impact or enable your ability to be able to manage forest fuels in the Otways moving forward?
Yeah, really good question. It actually it's almost twofold. It not only does it present challenges, it also actually presents opportunities to look later into autumn and into winter as an opportunity to undertake fuel reduction burning. But a drying landscape does, and I guess David's touched on it now, actually presents difficulties around managing some of our key assets like our wetter forest systems in terms of they actually become more available for longer periods of the year. But I guess looking to protect those assets, it actually provides opportunities to look at, I guess, some of our north-facing slopes or some of those forest communities that back onto those wetter forests, and we can start to look at how we apply fire into those, use fire as a tool to help manage and protect some of our other assets, such as our wet forests. But also too, and a good example of, I guess, applying fire different times of the year has been what we've been up to the last few years, particularly in the Carlisle and Anglesey Heathlands, around looking at late autumn, winter burning, about actually targeting the drier parts of our heathland communities to put fire in to break those landscapes up in order to protect some of the higher value assets within those vegetation communities, and particularly in our drier parts of the Otways, like the Anglesey Heath. Our higher value parts of those landscapes might actually be our wet swamps or our drainage lines. So burning in winter to target the areas around those higher value parts of the ecosystem actually provides a buffer or some security around if we do get a wildfire event, a large wildfire event in the Otways, that we've put some measures in or some protection around some of those higher value ecological assets in our landscape.
There's actually quite a few questions about planned burning, and I'm feeling like I haven't really got to all of the questions, and I'm sorry about that, but they've really come in thick and fast. Another question we did have, just as acknowledgement, and I think that maybe we'll do some follow-up around this, is also about the macropod, controlling macropods post-burns or post-unplanned fires, David. I'm sure you guys can see the questions too. So we'll take note of all of this. I am just aware of the time. We've already gone nearly 15 minutes over, and we've got a bit of housekeeping. I guess one of the things that we really wanted to get out of today's session, from particularly the presenters, is I suppose, a short snapshot of their opinions around what is the future of living in fire-prone areas. And Stephen, I'd ask you if you could go first. What is the future of living in fire-prone areas?
Well, the future is change, and we've been experiencing the change already. And so I think we need to look at what we already have been seeing, reflecting on it, and building it into how we plan going forward. And Aaron just spoke of that in terms of already finding its, different opportunities of when to undertake what fuel reduction burning you can do. But I think importantly, it's something which we need to take advantage of the breaks we'll get, because we'll also have tough times where we'll be, running very hard to deal with change. And so I think it's a matter of, looking at probably, scenarios and how would you plan for them, and how would we in advance be prepared. Be like a pandemic, actually. But I guess it's also, it is an opportunity. It's an opportunity to do things differently to how we would normally have done them. And I think, there's many streams in that. More streams I want to discuss now. But I guess, I think being informed, knowledgeable about what likely things will be happening and changing does prepare one to be better planning, a bit better planned for that eventual change. And so I think that's my takeaway message. And I think that we need to dissect it and not have this endless argument about fuel reduction burning. We need to be thinking about other factors as well that tie in with how we tackle various parts of that regime matrix I spoke of, because I think you'll find that the biomass one isn't going to be the critical. It'll help, but there'll be other factors that you'll need to be better thinking through in advance. In other words, when we have those significant periods of drought in the landscape, what does it mean in terms of the availability of our water resources to do with aerial, fire suppression? For example, there's a broader thinking that's required by landscape change. Sorry.
No, it's really lots of insight, and I think this is the beginning of this conversation. I mean, obviously we've been having these conversations for years, but I do think there's a raised awareness, and by starting these kinds of conversations, it's an onwards progression, isn't it?
Yeah, but even like seasons will start earlier. Fire seasons will start earlier. You'll need to have, plan it earlier. You'll need staff that will extend over longer periods of the whole summer, because you'll need the availability. So there's a whole range of logistical issues around what does that mean in terms of how government agencies and volunteers and the community generally prepare for them. Can the Falls Festival continue to be held in at Christmas each year? There's sort of planning issues, obviously, that need to be considered.
Thanks for that, Stephen. And David, same question to you. What is the future of living in bushfire-prone areas?
Well, I think Stephen's talk was really informative in the sense that, the primary driver of fire is climate and weather. And in more recent times, there's now started to be the science of attribution. So for a long time, people are saying, well, it's not possible to attribute particular events to climate change. Well, that's no longer the case. And that's been shown more recently with, for example, major wildfires in Queensland. Very high levels of attribution to climate change. So the reality is the world really has to do something about climate change. I have great concerns when I talk to my colleagues who have a long history of working in geology, and they've said, David, the world has been at 500, 600, 700, 800 parts per million in the past. You just got to realise that periods like the Eocene, temperatures were 4, 5, 6, 7 degrees warmer than they are now. So you can only imagine what fire behaviour might be like under those kinds of conditions. And so really to me, that suggests we've really got to come to terms with that. Now, there's such a lot of additional warming in the pipeline already. I think it's spot on to be thinking more deeply about what it means in terms of preparedness for fire. And I think Victoria really was strongly contrasting with New South Wales in terms of responses to fire this last fire season. This notion of mass evacuations of people under extreme and catastrophic conditions was, to my mind, the right thing to do to save people's lives. And I've had some experience of this from a family perspective and friends' perspectives in 2009. So I think preparation is obviously very important, but also knowing when to leave is also really important. It's quite clear that under extreme fire conditions, no matter how much hazard reduction burning's been done, it's not going to have much of a difference. And we saw that in Marysville, 2009. I gave the keynote address at a statistical conference in Marysville in December 2008, and you could barely see more than 50 metres in front of your face because of the amount of smoke that was around the town. Now, within a couple of months, Marysville was absolutely razed, completely destroyed, bar a few houses. And so, yes, that's a one-off example, but there are many others. And so we really do have to think deeply about responses to these things, much more so than we've done before. And I worry that royal commissions and commissions of inquiry are learning much more slowly than we should do, given how much good fire science there is out there, and how much understanding we now have of the critical role of climate and weather in what happens. So that prefaces my other comments about the relationships between the age of forests and fire severity. that sits underneath the main drivers of fire, which are climate and weather. And we've got to do things, we've got to deal with that and take the lead on dealing with that. Otherwise, Australia and California are not going to be aberrations. We're going to see it in many more places. And that's not something I want to see.
No, I don't think any of us want to see that. And like I said, this is really a great beginning to a conversation to raise all of our awareness about bushfire risk now, but also into the future. And that's really, you can't plan or prepare for things that you're not aware of. So on that note, I'd really like to pass out all of our thanks, about the amazing volunteer committee of Ada and Friends of Lawn, myself, and all of the participants. We've had over 200 people watching tonight, so that's an excellent turnout. I'd really like to thank you, David Lindenmayer. Thanks for your time. I know that it's at the end of another big working day, so I appreciate you being able to be here and speak so candidly and frankly. I think that's really accessible language. The data was profound. Your evidence base is obviously very solid, and it would be great, like we said, if you could send through some of those links and we will make sure we pass them on. And Steve and Farrell, thanks to you. Seeing those climate change modelling, the data that you've used is, again, really profound, and I'm sure a lot of people will be thinking long and hard about how we can support some kind of planning and preparation to meet that future, but also hopefully influence the change of what we're going to experience. I'd also like to thank Friends of Lawn, Mary Lush, what a dynamo, and all of her associates. Incredible initiative from the community. Aaron, thanks for coming along. I really appreciate your local input. And the man behind the scenes is Zach with all of the IT, and it's worked wonderfully in this new world of COVID. It can be a bit glitchy, so I appreciate your help, and Mandy Baker as well. Zach, if you could put up the last couple of slides just so we could promote the next session. See, I might have spoken too soon. Applauding the lack of glitches. Here we go. So if you've had unanswered questions today, we will try and follow up. I am thinking that some of those questions might be answered through the next two sessions. So the next session is on Monday. I can't quite see the time because it's under everyone's heads. With Janet Stanley and Kevin Tolhurst, two more eminent scientists in the field of the drivers of unplanned fire, which we really have touched on today as well. And there's a final slide where I think so if you want to send an email to me, any feedback, any other questions, if I can help direct them, I can forward them on to the Friends of Lawn or Aries Inlet District Association. Feel free. I hope you've enjoyed this session. And like I say, any feedback, greatly appreciated. So with that, we've got 1 minute until this session shuts down, but many thanks, people.
Okay, a pleasure. Thank you.
Thank you.
Thanks, everyone. Thanks, Mary. Thanks, David. Good to see you, David.
Likewise. Bye. All the best to everyone.
Thank you.
Take care. Bye.